Now we are looking at the size of ions. The lithium cation is significantly smaller than the lithium ion. So here you see that the size difference is significant. And then the chlorine anion or chloride ion is significantly larger than the chlorine atom. When we are comparing the radii of atom and also the radii of an ions, you can see that cations are much smaller than the atoms from which they come. So here you can see that lithium, it has a size of 152 picometer because lithium has 3 electron and 3 proton, whereas in the lithium ion it has 2 electron and still 3 proton. So these 3 proton, it will attract the valence electron more. That's why the size of the cation decreases. Now look at the comparison between fluorine atom and fluoride ion. Okay, so anions are larger than the atoms from which they come. Okay, fluorine has 9 electron and 9 proton, and fluoride ion has additional 1 electron, so 10 total electron and still 9 proton. So the addition of one or more electrons to the valence shell of atom results in a greater force of repulsion among the electrons. This repulsion causes the electrons to spread out. That's why the size of the anion increases. Besides comparing the size of atom with the cations or anions, there's another one type of ions, which is the isoelectronic ions. Okay, this is the atoms or ions with the same electronic configuration, meaning the same number of electrons. So the size of isoelectronic ion decreases with the positive nuclear charge increases. Okay, let's look first at the red side of the table. Okay, all the ions red in the red, you can see that the ionic radius decreases from 1.4 angstrom to 0.5. So the similarity of all these ions is that they have the same number of electrons. All has 10 electrons, but it has different proton number. So it has different nuclear charge. So the one with the higher proton number will have the smallest size because the ZEV of this uh, cation increases. Okay, now we look at the blue side of the table. So you can see that this anion has all 18 electrons, but the size decreases from phosphorus anion to chloride ion. So phosphorus has only 15 protons, so it has only the 15 plus positive charge of nucleus, and then that's why the size is bigger, whereas the chloride ion has 17 protons for the nucleus to attract the valence electron of the chloride ion, hence the size decreases. These are all another examples of isoelectronic ions. So again, they all has the same electronic configuration, but the ionic radius differs greatly with the increase of proton number. So it decreases with the increased proton number. So atomic radius or ionic radius depends varies from the least with the positive ion having the smallest radius, followed by the neutral or atom, and then the negative ion has always the largest size of atom. Some exercise for you. Choose the larger of each pair. So number 1, sulfur or its anion, calcium or its cation, bromide, anion or krypton. Comparing these two, the anion is larger because there are more electrons, which is 18 electrons for the 16 protons to hold. That's why the anion is larger than the neutral atom. Comparing calcium and its cation, which has less electron of 2, calcium atom is larger because its valence shell electrons have been lost to form Ca2+. The cation is always smaller than the neutral atom. So for bromide or krypton with the electronic configuration such as this, bromide is larger because it has fewer protons, which is 35, to hold the 36 electrons than does krypton, which has 36 proton. The more the proton, the higher the ZeV it has. That's why it is smaller. For isoelectronic species, the more negatively charged, the larger the atom or ion due to the effective nuclear charge. Here's another exercise. Arrange these species in the order of increasing size. You have argon, you have potassium, cation, and also chloride anion. First is you have to get the electronic configuration for all these ions or atom. So it turns out that although it has different proton number due to the loose and additional electrons, potassium and chloride ion has the same electronic configuration or the same number of electron with argon. So these are all categorized as isoelectronic species. So we have to decide which one is the smaller and which one is the biggest. So the size increase in the order of potassium cation is the smallest, followed by argon gas, and the largest is the chloride ion. Please take note on the proton number possessed by each species. You can see that potassium has the highest proton number, which gives potassium the highest ZeV, followed by argon with 18, and the least nuclear charge is by chloride ion. That's why chloride ion is the biggest.